This is section 6.2, solving linear equations. Start with the definition. A linear equation is an equation in which the variable has an exponent of 1 and the graph is a line. Obviously, the term linear means the graph is a line. There are two forms of a linear equation. The first is slope-intercept form, y equals mx plus b. In this form, the slope is the coefficient of the x term, and b is the y-intercept. The second form is called standard form, in which case we want both x and y terms on one side of the equation and the constant on the opposite side of the equation. Properties of equality. Properties of equality are used to solve equations for a specified variable. The four properties of equality are the addition property, the subtraction property, the multiplication property, and the division property. Let's take a closer look at each of these. First, we have the addition property. It states that the same real number or expression can be added to both sides of an equation without changing the solution set. You can see in our example, we start with the equation x minus 3 equals 6. In order to solve for x, we add 3 to both sides of the equation. We can add 3 to both sides of the equation because of the addition property. On the left side, negative 3 plus 3 is 0, leaving us with just x. And on the right side, 6 plus 3 is 9. Therefore, we end up solving for x equals 9. The subtraction property is similar to the addition property, except obviously we're subtracting. So in our example, you can see that we are subtracting 3 from both sides of the equation. And of course, 3 minus 3 is 0, so that leaves us with just x on the left side of the equation. And 6 minus 3 is 3, so that leaves us with x equals 3. The multiplication property, once again, very similar, except we're multiplying on both sides of the equation. So if we start with the equation x over 3 equals 7, and we want to solve for x, we're going to multiply both sides of the equation by 3. On the left side, our 3 in the numerator will cancel with our 3 in the denominator, leaving us with just x. On the right side, we have 7 times 3, which of course is 21. So solving for x, we get x equals 21. And finally, we have the division property. If we start with 5x equals 15, in order to solve for x, we need to divide both sides of the equation by 5. On the left side, our 5's will cancel out, leaving us with just x. And on the right side, let me go back here. On the right side, we have 15 divided by 5, which of course is 3. So we solve for x and get x equals 3. Now, individually, these properties are all quite simple and easy to see in examples. But we need to use, most of the time, we need to use multiple properties at once. All right, let's talk about actually solving a linear equation. All right, first step, simplify the algebraic expressions on both sides of the equal sign. In order to do this step, you're going to use things like the distribution property, or you're going to combine like terms. We worked on this last time in class, so we should be able to do step 1 very nicely. All right. Next, step 2, once we've simplified, step 2 is to collect all of the variable terms on one side of the equation and all constant terms on the other side. Right? And to do this, you're going to use the addition and subtraction properties, which we just went over. Step 3, isolate the variable and solve. Well, in order to do step 3, apply the multiplication and division properties. And finally, step 4, check your solution by substituting back into the original equation. Alright, let's actually solve some equations now. We'll start out with some easy ones and get to some more difficult ones as we go. So number 1, 5x equals 45. We want to solve for x, so very simply, since 5 times x is on the left side of this equation, we want to undo that multiplication, so we're going to divide by 5 on both sides. These 5's cancel out, leaving me with x, and 45 divided by 5 is 9. Number 2, 5x plus 3 equals 18. Well, notice that 3 is a constant and 18 is a constant, but 5x is obviously an x term. So what we want to do is we want to move the 3 over to the right side to combine it with the 18. In order to do this, we're going to subtract 3 from both sides. Cancels out over here, leaving us with just 5x. 18 minus 3 is 15. So you can see we've gathered our variable term on the left and our constant on the right. Now to get x by itself, we're going to divide both sides by 5. 5's cancel out, leaving us with x equals 15 divided by 5 is 3. Alright, starting to get a little more difficult. On the left side of the equation in number 3, we have a more complicated algebraic expression. We need to simplify this algebraic expression before we can do anything else. So let's simplify it. Notice the minus sign right there. We're subtracting this entire quantity, which means we need to distribute the negative sign. Remember, you can treat that like a -1, and we're going to multiply it by each term in parentheses. So we end up with 5x, leave that alone. -1 times 2x is -2x, and -1 times -10 is +10. We'll write the rest of the equation equals 35. Now we can combine like terms because the 5x and the -2x that you see here, 5x, -2x, those are like terms because they're both x terms. So 5x minus 2x is 3x plus 10 equals 35. All right, now we've simplified the left side of this equation. Now it's time to collect variable terms on one side and constant terms on the other. Well, since 10 and 35 are both constants, we want to combine those. 3x obviously is a variable term. So let's move the 10 over to the right side by subtracting 10 from both sides. All right, in this case, we're going to get 3x equals 25. And now we can divide both sides by 3, giving us x equals 25 divided by 3. 3 doesn't go into 25 a whole number of times. You can leave it as an improper fraction, or you could write it as a mixed number. All right, number 4. Again, we're getting slightly more complicated as we go. So on the left side of this equation, the first thing we need to do is distribute the 3. So we end up with 9y minus 3. On the right side, we need to distribute the 4. So we get 12 plus 12y. Next, we need to get our variable terms on one side and our constant terms on the other side. So you can see that we have some y terms here and here, and we have our constant terms here and here. So let's mix and match, or not mix and match, but let's move things around so we can combine like terms. All right, I'm going to choose to subtract 9y from both sides. Notice I line it up with my other y term. That cancels out, leaving me with -3 equals 12. 12y minus 9y is 3y, positive 3y. Now we need to move the 12 over to the left side, so we're going to subtract 12 from both sides. Those cancel out, leaving me with just 3y on the right side. -3 minus 12 is -15. Now that I've isolated the y term on the right side and the constant on the left side, I'm going to get the y by itself completely by dividing both sides by 3. Those cancel out. Y equals -5. All right, moving right along here. Number 5 looks kind of complicated. Don't get intimidated by what things look like. Carry through the process. So the first thing we need to do is simplify the algebraic expressions on each side of the equation. So let's start over here on the left side. Let's simplify this. Notice we have two x terms, so we can combine like terms. -3x plus 5x would give us 2x plus 5. Since 5 is our only constant, we're going to leave it alone for right now. Now we simplify the right side. Again, we have two x terms. 4x minus 2x is 2x. And again, 5 is a constant. So we have 2x plus 5 equals 2x plus 5. That's interesting. Same thing on both sides. All right, let's get our variable term on one side and our constant terms on the other side. So if I want to move 2x over to the left, I'm going to subtract 2x from both sides. But interestingly, it's going to cancel out on both sides. And our 5s, now we have 5 equals 5. If we tried to get those on the same side, they would end up canceling out also, leaving us with 0 equals 0. All right, now there's something to be learned here. Anytime you solve an equation and you end up with a true statement like 0 equals 0, that means that the solution to this equation is all real numbers. And there's your symbol for all real numbers. That means that you can plug any number into this equation for x, and it will satisfy the equation. Let's go to number 6. All right, first thing we need to do is simplify the left side of this equation. So we're going to distribute the -3 first. So let's rewrite 9x. -3 times -5 is positive 15. -3 times positive 3x would be -9x. Let's rewrite the right side. All right, on the left side we have like terms. We have a 9x and a -9x. Well, 9x minus 9x would be 0x, or nothing. It's gone. So these cancel each other out. This leaves us with 15 equals -15. Now, you could try to combine these if you wanted to. Let's say that we subtracted 15 from both sides. These cancel out. 15 minus 15 is 0. And on the right side, -15 minus 15 is -30. Now, notice what we have. We have a false statement. In number 5 over here, we had a true statement. 0 does equal 0. But now what we have is we have a false statement because 0 does not equal -30. So what a false statement tells you is that there is no solution. There is no number that you could possibly come up with, plug it into this equation in number 6, and have it satisfy the equation. So again, to sum up on this slide, number 5, true statement means all real numbers. False statement in number 6 means no solution. All right, so that gave you several good examples of equations and how to solve them. Review those examples if you need to. Review the properties of equality, because those are the tools you're going to use to solve equations. This has been section 6.2, Solving Linear Equations.